Hey guys, what's up? It's me, Rojas. Welcome back to the channel, to the calculus channel. Anyway, I decided to go ahead and teach the rest of the lesson from Friday on here. We just had one page left. I already taught you how to find normal derivatives, and by normal I mean just algebraic. We left off with the derivatives of exponential function and ln. They're relatively easy. So the only thing here that I'm going to say is here this function e to the x is the only function in the world that will have itself as the derivative, and we'll talk about why tomorrow during class. But in other words, f of x equals e to the x, then f prime of x is also e to the x. Now when we have numbers anywhere in there mixed up, of course it'll work different, a little different, but again we'll talk about that later. And also here, your function ln of x, the derivative is 1 over x. Easy. Okay, so let's go straight into the first one here, part A. What is the derivative of ln x cubed? Well, first we have to rewrite it, okay, because we cannot go ahead and use this here up here because there's a little exponent of 3 here. So it goes back to your algebra 2 days where you rewrite things, and we can always rewrite this as f of x is equal to 3 ln of x. Okay, they are equivalent. So now I can go ahead and take the derivative. So it will be f prime of x equals 2. Well, constants, remember when we were doing limits, we would leave them alone. We do the same thing everywhere. We're gonna leave it alone, so it would still be 3. Parentheses, derivative of ln is just 1 over x. So just rewrite it, make it look pretty. It will be 3 over x. Because remember, if I have a fraction, you can make everything a fraction by writing an invisible 1, multiplying straight across. 3 times 1 is 3, 1 times x is x. So 3 over x is my derivative. All right, part B. Again, rewrite. And again, it goes back to your algebra 2 days. Whenever you are multiplying, you can separate them by adding. So I would have g of x, which is the original, is the same thing as having ln of x squared plus ln of e to the power of x. Okay, we can still rewrite things. So g of x equals 2. Same thing with the 2 here, with the exponent, I can just move it to the front. So I would have 2 ln x plus, all right, when you have ln and e literally right next to each other, like I do here, they cancel. And now that x is not just the base, so plus x. Now I can go ahead and take the derivative of that. So I would have g prime of x is equal to, again, that 2 is just a constant. Leave it alone. Derivative of ln is 1 over x plus derivative of x is 1. Make it look pretty. 2 over x plus 1. All right, letter C. I had to rewrite this too. It's this first term here, I don't have to because I can just go ahead and take the derivative of that, which is just 1 over x. But this guy, I have to rewrite. So I would have ln of x minus x to the negative 1. The power rule, right? That I taught you on Friday. So I would have h prime of x is equal to, derivative of ln is just 1 over x minus, well, remember your power rule, move your exponent to the front. So I would have negative 1, but you see how that negative will cancel with that minus here? So I will have plus. And a 1 is invisible, so I'm not going to write it. So I would have x, subtract 1 from the exponent, negative 1 minus 1 is negative 2. Again, rewrite it, make it look pretty. So I would have h prime of x is 1 over x plus 1 over x squared, because we do not like negative exponents, right? It's kind of hard to record with one hand and write with the other. All right. Again, letter D is very much like letter B up here. Here you are multiplying, so here you are dividing, which is the opposite. So if we are adding here, we are subtracting here. So rewrite it. I would have, sorry, it keeps blurring. Okay, there you go. I would have ln of 2e to the power of x minus ln of 3x. Okay. I still have to rewrite. Okay. That 2 right there, you see how it's in between the e and the ln? They cannot cancel. I have to do something with it. Well, 2 and e to the x are being multiplied, so we can go ahead and separate those by adding. So I would have ln of 2 plus ln of e to the x minus ln of, same story here, you're multiplying, so I would have ln of 3 plus ln of x. And here, let me, okay. Don't forget your parentheses. Every time you have a minus sign, please go ahead and do parentheses, because that minus sign changes everybody's sign after. Okay, it's very important. Here, I didn't do that because everything here, well, I'm multiplying it out, so I'm adding, so it doesn't matter. But over here, I have that big minus. So anyway, I can just go ahead and rewrite what I have. So ln of 2 here, ln and e cancel, so I would have plus x minus ln of 3 minus ln of x. At that point, I can go ahead and just take the derivative. So I would have y prime is equal to, well, ln of 2 is just a number at the end of the day, right? And remember, the derivative of a constant is 0. So 0 plus the derivative of x is 1 minus 0 minus 1 over x, because the derivative of ln x is 1 over x. Of course, I didn't have to write the zeros, but I'm writing them here because I had a lot of people skipping on Friday. So y prime is equal to 1 minus 1 over x. That's what I have left. All right, 2 more. Again, rewrite, okay? So I would have ln of 4x cubed plus ln of e to the x. That is your first step. You can further rewrite that part. Ln of 4 plus ln of x cubed plus ln and e cancel, so the only thing that stays is x. Okay, and again, I can further rewrite this part here by moving that exponent to the front. So I would have ln of 4 plus 3 ln of x plus x. Now I can take the derivative. So I would have f prime of x is equal to, well, derivative of a constant is 0, so that goes away. 3 ln x, well, 3, leave it alone, it's just a constant. Derivative of ln x is 1 over x plus derivative of x is 1. So I would have f prime of x is equal to 3 over x plus 1. Oh my gosh, it really is hard to record and write with one hand. Okay, last one. I would have to rewrite. The only part I need to rewrite is the second term here. I have to move the denominator up to the numerator. So I would have, well, here first, I'm not going to skip any steps. Get rid of the root. Remember I said that on Friday, every time you have a root, get rid of it, rewrite it with a fraction as an exponent. Or exponent as a fraction. So I would have x to the power of 2/3. Okay, now I have to move this to the numerator so that I can use the power rule. So I would have pi e to the x minus x to the negative 2/3. Okay, now that's easy to take the derivative of. I would have g prime of x is equal to, well, pi is just a constant, leave it alone. The derivative of e to the x, guys, is just e to the x. Minus, move your exponent to the front here. So I would have negative 2/3 x. And take away 1 from your exponent. So I would have, here, I'm going to say detour. take away 1 from the exponent, so negative 2/3 minus 3 over 3. Whatever denominator I have, I just make it common denominator. Easier. Negative 2 minus 3 is negative 5. Keep that common denominator. So my new exponent is negative 5/3. So that is my answer, but I just have to simplify it, make it look pretty. So I would have g prime of x is equal to pi e to the x. Negatives cancel, so plus. The 2 here is the numerator, so please keep it as such. 3 is the denominator, and move this x to the power negative 5/3 to the denominator because you cannot leave negative exponents, so x to the power of 5/3. And that is your final answer for part F. Oh my gosh, I cannot even underline that. I'll just leave it like that, okay? So here are the rest of the problems, which should be your last page of the notes, okay? Shortly, I will upload a few of the problems on your homework. Hopefully this helps you out. Because tomorrow, I'm not sure about the teaching conditions. You guys saw how the whiteboard that I was using on Friday, it was very bad. Technology was very bad, so it was kind of difficult to teach. That's why I decided to finish it here. Anyway, I will see you guys tomorrow, and I will upload the second part, which is the homework part, in a bit. Love you guys. See you tomorrow. Bye. Alright guys, so here is the second part. I'm going to work a few of the problems on the homework. If you already did them, just check your work. Especially if you were not in class on Friday due to homecoming preparation. I hope this really does help you. So because of that, I'm gonna start really easy. Like number 1 is relatively easy, and then I will continue from there. So for all of these, we have to find the derivative. Number 1 is really easy. Derivative of y is equal to any constant in the world, just as long as it's just a number. Derivative will always be 0. It makes sense because whenever you graph a constant, your graph will look like a horizontal line, and the tangent of that horizontal line is itself. So that was easy, and I'm not gonna go in order, so let's skip to 3. Derivative of this guy, we have to rewrite x to the power of 4. So I would have x to the power of negative 4 minus 4 cosine of x, okay? Well, remember for sine and cosine, I taught you guys this little acronym, DSC, DISCO. Well, derivative of sine is cosine, but derivative of cosine is sine, negative sine, sorry. Negative because you are going backwards. So whenever you're reading normal, from left to right, derivative of sine is cosine, positive. But whenever you are going the opposite way, it's gonna be negative. So derivative of cosine is negative sine. DISCO, that's how I remembered it in high school. It really does help. Okay, so I would have y prime is equal to, move your exponent to the front, so you would have negative 4x to the power of, subtract 1 from the exponent, so negative 5. Minus constant, leave that 4 alone. Derivative of cosine, well, derivative of cosine is negative sine, you're going backwards. The negatives will cancel, guys, so I would go ahead and do a plus sign already, and it'll be sine here. And then lastly, just rewrite this first part here as without the negative exponent. So I would have negative 4 over x to the power of 5 plus 4 sine x, and that will be my derivative. Okay, let's look at number 2. Y, oh my god, I don't know why it keeps blurring out. Y prime is equal to, move your exponent to the front, 9x, subtract 1 from the exponent, so the derivative of the first term is 9x to the power of 8, plus 3 is just a constant, so bring it down. Derivative of tangent, we learned on Friday that it was secant squared x. So that is my answer for number 9. Let's work on 4. Rewrite, as soon as you see a radical, any root of any kind, rewrite. So I would have x to the power of 1/3 plus 7e to the x, okay? Anyway, for those of you wondering where I got that one from, well, remember there's an invisible one here, okay? So then I have y prime is equal to, bring the exponent to the front, so 1/3 x to the power of, take away 1 from 1/3, detour here, 1/3 minus 3/3, negative 2/3. So negative 2/3 plus 7 is just a constant, leave it alone. Derivative of e to the x is just e to the x, okay? Now, of course, you have to rewrite the first term here. So I would have equal 1. That 1 there is the numerator, so please keep it like that. 3 is the denominator, keep it down there. You just have to bring down this x to the negative 2/3. So x to the 2/3 plus that second term. So it's gonna be this part. I'm sorry, that's so messy. Which one else can we do? I'm just gonna, like I said, skip around. Let's do number 10. I already see sine and cosine, so automatically think of disco, okay? S prime of t is equal to, power rule, bring the exponent to the front, so 3t, subtract 1 from the exponent, plus move the derivative, the exponent to the front, but whenever there's a number there, multiply them, okay? So it'll be 12. T, 2 minus 1 is 1, and a 1 is invisible, so I'm not gonna write it. Minus 2, constant, right? Derivative of cosine, well, derivative of cosine is negative sign because you're going backwards. So negative sign, but that negative will cancel with this minus sign, so plus sine of t plus 9. Derivative of sine is cosine, and you not negative, so that'll be it. So your derivative of that is 3t squared plus 12t plus 2 sine t plus 9 cos t. Okay, I'm not gonna even circle that. Number 11, FOIL it out, or not FOIL it out, distribute that x, okay? So I would have x to the power of 4 minus x, and that's really easy to take the derivative of. So h prime of x is equal to 4x cubed minus 1. That's my answer. Okay, number 13, very similar. You just have to FOIL it out. Let me skip to the second page here. Okay, let's see. Let's do, sorry guys, I'm just looking at the problems. Rewrite number 15. Okay, I would have 2 sine x plus x to the negative 2, because then you can just go ahead and use the power rule for the second term. And of course, you're going to use disco again. Okay, so let's just finish it off. So f prime of x will be equal to, that 2 is a constant, leave it there. Derivative of sine is cosine. Bring the exponent to the front, so minus 2x, subtract 1 from the exponent, so negative 3. Okay, of course we have to rewrite because that negative 3 cannot stay there. So f prime of x is equal to 2 cos x minus 2 over x cubed, and that's my answer. Number 16, break it up. That x belongs to every term on your numerator, so it would be 5x cubed over x plus 7x squared over x. Okay, and the x's cancel. 1x cancels with 1x here. This x cancels with 1x there. So I would have 5x squared plus 7x. Now I can find the derivative easy. So y prime is equal to 10x plus 7. 18 is very similar. Let's work on 17. Same thing, it's just that you have to give the e to the x to every term on the numerator. So you would have 3e to the x over e to the x plus 2e to the 2x over e to the x. Okay, e to the x is cancel. And here, guys, it's very important that you notice this is an algebra 2 property as well. You have common base of e. Just subtract the exponents because you are dividing. And 2x minus x is 1x, but the 1 is invisible, so it will just be e to the x. In other words, this is what you have left. Okay, now I can take the derivative of that guy easy. I would have y prime is equal to, well, derivative of any constant is 0, so I'm not going to write that. And this guy, well, the 2 is a constant, leave it alone. And the derivative of e to the x is just e to the x. So that's my answer. Same thing. This one, just rewrite it without the radicals here. Here, separate it, give the 3x squared to both terms here. Which one else? Oh, let's work on 22. Here we have to rewrite. This is difference of squares because this can be rewritten as 2 cubed, right? 2 cubed is 8, so I would have that x minus 2. Again, difference of cubes. Oh, I think I said squares but the first time, but guys, it's a difference of cubes. You follow a formula for this. The first part is this. You keep this guy exactly the same, x minus 2, without the cubes, right? And then you would have x squared, the opposite sign of whatever you're doing. So here it'll be x plus these two multiplied, so 2x, the basis. And then you always add at the end the second term squared, and 2 squared is 4. All over x minus 2. Okay, x minus 2, they cancel, so this is what you have left, x squared plus 2x plus 4. And the derivative of that is really easy. Y prime is equal to 2x plus 2. And that's it, because the derivative of 4 is 0. So that'll be it. Okay. All right, let's do maybe a couple more. Okay. Which one? 24 is relatively easy. You just have to rewrite this second part here, the ln part. I would have 5 sine x minus 2 ln x. Okay. Oh, that was terrible. I wrote on the next one. And we're gonna use disco again. So dsc. Derivative of sine is cosine, and it's positive because we're going to the right. So I would have f prime of x is equal to 5 cos x minus the 2 is a constant, leave it alone. Ln x, the derivative is 1 over x, so it would be over x here. That's it for that. I'm just gonna help you rewrite some of these here. Like number 26, I would have ln of pi plus, because you are multiplying pi and x cubed, right? And then I would have 3 ln of x. I just went ahead and moved the 3 here. That would have been here because it's an exponent. I just moved it to the front. Minus 2 x to the power of negative 3 over 2. Okay, and just take the derivative of all that. So y prime is equal to, ln of pi is just a number, it's a constant, so the derivative is 0. I'm not going to write that, so that goes away. 3 is a constant, ln x is 1 over x, so 3 over x. And then I would have minus 2, move the exponent to the front, so negative 3 halves, x to the power of, subtract 1 from the exponent. Well, think about it, negative 3 over 2, here, let's just write it out, minus 1, I'm gonna make it 2 over 2, so negative 5 halves, negative 5 over 2. So that's my new exponent. Okay, make things look pretty. First, these 2's cancel, negative negative cancel to a plus, so I would have y prime is equal to 3 over x plus 3 over x to the 5 halves. So that's my answer to number 26. You have to do a whole lot of rewriting here. Just remember that the derivative of tangent, well, actually, no. This one's tricky because this first part, see, it almost caught me right now. This first part is just a constant, guys. For tangent of pi, it doesn't have an x in it, so that's just a constant. So its derivative is 0, so that just goes away. So you just have to worry about rewriting this part here by moving the 2 to the front here. Now for numbers 30 and 31, find the equation tangent to the line. Remember, for an equation tangent or normal line, you need two things, and that is a point and a slope. Okay. And let's see what's going on here. Okay, give you a hint for numbers 32 and 33. I'm telling you here, find the points of the graph where the tangent line is 0. Well, in other words, the tangent line is your derivative, right? So, and which is your slope from algebra 1. So I'm telling you here that your slope is 0. Okay, so you would need to find the derivative and set it equal to 0 and solve. And you will get your x. And to get your y, to get the full point, x comma y, you would plug in whatever x you found by solving. When you set the derivative equal to 0, plugging in those x values into your original equation. And that will give you your y values. And here, 34 and 35, find the equation tangent to this line at this point, okay? Like, for example, for 34, again, you need two things, a point and a slope. Point and a slope. Let's just go ahead and do this one. Your point is easy because I'm already telling you your x is 4. So your y, you literally just plug in 4 to your original. So I would have f of 4 is equal to 6 times 4 is 24 minus 16. Square root of 4 is 2. 24 minus 16 times 2 is 32. 24 minus 32 is negative 8. So my point is 4 comma negative 8. Okay, and now I just need the slope, which in other words is your derivative. So f prime of x is equal to derivative of 6x. Remember, when the x has a 1 as an exponent, it's just the coefficient. So it would be 6 minus 16. Well, square root of x is x to the 1/2. So the exponent, move it to the front. X, subtract 1 from 1/2, and we did it so many times on Friday. I bet you guys remember that is negative 1/2. And just simplify that. 6 minus 16 divided by 2 is 8. So 8x to the negative 1/2, which we write as 6 minus 8 over square root of x. Okay. Now to find your value for the slope, you just have to plug in 4 into your x here. And that'll be my m, my slope. So I would have m is equal to 6 minus 8 over square root of 4 is 2. 6 minus 8 divided by 2 is 4. And 6 minus 4 is 2. So that's my slope. Okay. Use point slope form. And I'm just gonna go ahead and write on the next one. Point slope form, remember, is y minus y1 is equal to m x minus x1. Y minus your y1 is your y value here, so negative 8, but it'll cancel, so the negatives will cancel, so y plus 8 equal to m. Your slope is 2. X minus x1, which is your 4 here. Remember, if we had asked for the normal line instead of tangent line, it is literally all the same steps, except that your slope, you would have to flip it and change the sign. So change it from positive to negative or vice versa. And I will stop here. Okay. I will see you guys tomorrow. Bye.